Now we're going into presentation 2, which is where we're going to identify the positive and negative terminals of the batteries, and we're going to make the closed circuits. Then we're going to tell the children that every battery has a negatively charged side, which is an anode, and you can see the minus for negative, and it also has a positively charged side, which is called the cathode. And on the AA battery, the anode, which is the negative side, is flat, and the positive side protrudes out with a circular point on the top. And the ends of the batteries are also called terminals. On the coin battery, I don't know if you can see it, but there's a plus on this side for the cathode, but the anode, which is the negative side, does not have anything listed on this one. And that's pretty consistent across coin batteries, so you'll just need to know what the positive side is and then figure out that the other side must be negative. So that is how batteries work. They have chemicals inside, and when the chemical reaction happens, electrons flow through something that is conductive, which is the metal part, and that is how the circuit is made, and that is how electricity is able to flow and power our machines. So that is the battery. Then under letter C, you're going to say, show the children the positive side and the negative side on the AA battery holder. And I saw something actually kind of cute that helps me remember this, which is that if you imagine that a AA battery is like a rocket, the spring helps it launch. See, the spring helps it launch. And most of the time you can see that there's a negative down there, I don't know if you can see it, and a positive at the top, and it also shows you a picture of where it goes. Now, it's not always the spring that's on the bottom, but most of the time it is. So then you'll go ahead and attach that. Then we're going to go with the LED. And on the LED, the positive side is the longer side. I don't know if you can see, but this is just slightly longer than this. And so the positive side is going to go to the flat side of the coin cell battery in order to make the LED light up. And if they did it the other way, it would not light up because the electricity is not flowing properly through a closed circuit. Even though this is only 2 items, it's a closed circuit because you see that there's metal touching metal, and inside there's more metal touching each other. So that is a closed circuit also. In an open circuit, nothing really happens. So the next lesson, that was letter D. The next one is letter E, where we remind children that a closed circuit is one where the circuit is fully connected and an open circuit is not fully connected. So electrons, which are what make electricity, which are part of atoms, can flow through a closed circuit, but not an open circuit that's not fully connected because they kind of get stuck. There's no place for them to go. Then we're going to go to letter F, which is where we demonstrate how you make a closed circuit with the motor. And we're going to connect the alligator clip leads to the correct positive and negative wires on the AA battery holder with the metal of the alligator clip leads connected to something that is metal. And again, the battery holder, I don't know if you can see, but it's got this plastic shielding coating, but at one point there is no shielding, and you actually need that to make the circuit happen. So we're going to go ahead and connect. I don't know if they can see because it's covered, but it's a clip, kind of like, you know, a clip that they might use for a magnet. And the reason they call it alligators, you can kind of show the teeth. So connect the red wire to the red wire, and it has to be touching the metal. Connect the black wire to the black wire. I mean, it's actually the leads. And I don't know if you can hear that. I'm pretty sure you can't see it, but it's spinning and buzzing. And in a little while, we're going to put a little piece of tape on it so that you can actually see it moving. To do that, I'm going to go ahead and unhook one side of it to open the circuit, and you can't hear it anymore and it's not spinning anymore. This part of the motor is called the shaft, and what we're going to do is go ahead and take a piece of tape. Okay, I found my scissors. So what I'm going to do is take a piece of tape And you don't actually need to measure this tape, just about that big. And what you're going to do is you're going to put the tape on the shaft, but not on the side, because the idea is we want this thing to spin. So put the middle of the tape on the shaft and then close the two ends to make sort of a flag, like that. And then what we're going to do is we're going to close the circuit and they're going to be able to see it. There it goes. So this is going to be part of our final project, so you want to go ahead and leave that tape on there. For letter I, we're going to do some things that are on purpose designed to fail. And this is how we show the children how they can debug their Artbots if something like this were to happen. One of the things that we're going to do is we're going to say, what happens when you attach the alligator clip lead wire to the plastic coating of the AAA battery holder wires? And they might not know the answer, so we'll say, well, let's find out. So this time, go ahead and take the alligator clip and attach it just to the plastic coating on the wire. And if you'll notice, our flag is not moving. And you can ask, why do you think that is? And some of the children might say, oh, because it's not connected to the metal, or it's not a complete circuit. And if they don't answer for you, you can say, well, try to put it in different places. So that's something you can do. And anything I'm telling you here is just a suggestion. I know there are a lot of people watching that are teachers, and you can phrase it however you like. Okay, so that's one thing, is attaching to the shielding wire, which the shielding coating, which is not going to complete the circuit. Another thing is, what happens if you touch the metal of the alligator clip to the metal of the wire from the AA battery holder? So let's find out. What if you just touch it? If you just touch it, look, it still completes a circuit. And you can say, why can't we just do this? Why can't we just, think that the circuit is complete and go about our day? And the answer is because it won't stay on. So let them answer. Let them have an opportunity to answer and make these discoveries themselves. And what happens if the battery is upside down in the AA battery holder? And let's find out if the terminals are in the wrong place. So now we have the battery with the spring on the positive side of the battery. And as you'll notice, the motor's not running. And the reason is because the battery is not positioned properly inside the battery holder. And it is stuck, so I'll go ahead and pause the video and try to get it out.